Approximately 50 years later, the new mission from America has made history by landing on the moon. Finally, the Odyssey spacecraft has sent back images after reaching the moon, capturing terrifying scenes during its descent. This mission marks America's first landing on the moon after the Apollo missions. You might be curious about how the spacecraft landed there, and in this video, we'll show you images taken during its descent. We'll also explore the current status of the lander on the moon, how long it will remain operational, and the purpose of its mission. This episode of Cosmic Discovery will provide detailed insights. So, if you haven't subscribed to our channel yet, make sure to do so now. Odysseus lunar lander, also known as NOVA-C, was launched on February 15, 2024 by a SpaceX Falcon 9 rocket, and on February 22, 2024, Odysseus is scheduled to land on the south pole of the moon, providing information on scientific mysteries and cosmic. It is a treasure trove of secrets. This is why most lunar missions attempt to land on the moon's south pole. Odysseus, the first commercial lander to reach the moon, has achieved many achievements. Odysseus's soft landing on the moon's south pole not only marked the United States' return to the moon for the first time since Apollo 17 in 1972, but also made the US the second country in the world to reach that area after India, which on August 23, 2023, Chandrayaan-3 landed smoothly at the coveted spot. Odysseus covered an impressive distance of over 965,606 kilometers to reach the moon. Also known as the NOVA-C lander, it holds the distinction of being the first spacecraft to employ meta-propulsion for navigation between Earth and the moon. Carrying 6 NASA payloads, the mission's primary objectives were to showcase the capabilities of a commercial lunar lander and conduct scientific experiments and measurements on the lunar surface. Nevertheless, the lander's takeoff and landing posed challenges, requiring it to navigate hazards, adjust its trajectory, and control its speed and orientation. Despite successfully landing on the moon, it unexpectedly tilted on its side, leading to a loss of communication with Earth and an early conclusion to its operational time on the lunar surface. Moreover, the lander touched down in a level and smooth region near the rim of Shackleton crater, deviating less than a mile from its originally planned landing spot. The chosen site, situated near the moon's south pole, holds potential for water ice and other resources that could prove beneficial for future human missions. Now, let's delve into the captivating images captured by the lander. The initial picture, snapped by the camera positioned atop the lander and pointing downward, unveils the lander's shadow, the dust clouds, and undulations produced by its engine. It unveils the rugged lunar terrain, offering a glimpse into the challenging landing conditions. Captured at an altitude of approximately 50 meters, this image boasts a remarkable resolution of about 5 centimeters per pixel and was swiftly transmitted after landing, marking the debut image from the lunar surface. Another captivating image, shared by Intuitive Machines, showcases the spacecraft's descent into the Malapert region near the moon's south pole. Additionally, a third image, captured by NASA's Lunar Reconnaissance Orbiter, features the lander with a guiding arrow. This high-resolution image, taken at an altitude of around 100 kilometers, presents a stunning resolution of about 1 meter per pixel. The Odysseus lunar lander, having successfully touched down on the moon, finds itself in a continuation of its mission. The lander retains crucial data and information to relay back to Earth, with the possibility of conducting additional experiments and measurements on the lunar surface if deemed feasible. However, ongoing challenges and limitations persist in operating and communicating with the lander. The lunar environment, characterized by its harsh and variable conditions, along with the lander's constrained power and bandwidth, present persistent hurdles. A noteworthy challenge impacting its survival and functionality is the occurrence of a sun outage. This phenomenon transpires when the sun moves behind the moon, disrupting communication between the lander and Earth. Taking place twice a year around the equinoxes and lasting about 2 weeks during this period, the lander is unable to send or receive signals or commands from Earth, relying solely on its internal battery and memory. The sun outage is expected to commence on March 4th, 2024 and wrap up on March 18th, 2024. This grants the lander just a handful of days to communicate and function on the Moon before transitioning into an extended quiet phase. The team is putting in concerted efforts to make the most of this time frame, transmitting abundant data and information to Earth and undertaking a multitude of experiments and measurements on the lunar surface. Additionally, they are working towards enhancing the lander's power and bandwidth efficiency while preparing for the impending sun outage and its potential impact on the mission. Why do most space agencies want to go to the South Pole on the Moon? Odysseus landed on the South Pole of the Moon, a treasure trove of scientific mysteries and cosmic secrets. Some of the planned missions that aim to reach the Moon's South Pole include NASA's Artemis III, which aims to make history by landing the first humans on the Moon's South Pole. The objective is to determine the feasibility of using these assets for future sustainable space exploration missions. The lunar poles have an environment that represents the diversity of Earth, which is why their discovery will help scientists gain information about what Earth was like billions of years ago and whether it will be possible to colonize the Moon in the future. Reserves of water ice lie buried beneath the Moon's surface, particularly beneath the poles. Odysseus's goal is to explore the South Pole and conduct experiments there to understand the region's unique topography and geology. The primary purpose of the spacecraft is to investigate how water ice could be used for future propulsion and life support on the Moon. Such experiments will help scientists understand how these reserves can be used to extract water, oxygen, and fuel for future missions to the Moon, Mars, and beyond. Odysseus is equipped with 5 NASA payloads and commercial cargo. NASA selected Intuitive Machines to build a lander as part of the space agency's Commercial Lunar Payload Services Initiative, CLPS, in which a commercial firm receives a contract. Payloads are capable of conducting scientific experiments to make fascinating discoveries, utilize resources, and gain insights that will allow scientists to develop lunar infrastructure, all of which are important for designing roadmaps for future space exploration missions. Most importantly, the knowledge gained is expected to help scientists learn how humans can solve the challenges of living and working on the Moon. This is a big step towards realizing humanity's dream of Homo sapiens becoming a multiplanetary species. Coping with these setbacks and challenges is not just disheartening, but also a source of valuable lessons. Let's consider potential solutions and alternatives to prevent or minimize similar issues in future missions. To start, diversifying landing sites, trajectories, engines, and landing legs could bring about improvements. Future lunar landers might benefit from exploring different landing locations, employing various trajectories, be it more vertical or horizontal, to navigate hazards and adjust speed and orientation. Experimenting with different engine options, such as electric or hybrid propulsion, could mitigate dust plumes and reduce fuel consumption. Additionally, incorporating alternative landing legs like foldable or retractable ones may boost stability and flexibility. The second solution entails integrating more sensors, cameras, or satellites, including radar, LiDAR, or infrared technologies to meticulously measure and map the lunar surface. This heightened data accuracy can contribute to improved navigation and decision-making. Lastly, enhancing safety and survivability involves integrating additional backup and contingency systems like robot arms or rovers. These systems offer supplementary support and capabilities to address unexpected challenges. I hope you enjoyed this video. It was informative and insightful about the challenges faced by the lander and possible solutions. Share your thoughts on the lander, its mission, and the future of lunar exploration. You can subscribe to Cosmic Discovery channel to get daily updates related to space missions.